Today we're on page 3 of your second chapter 4 notes packet, and this one is section 4.8 inverse functions. We're going to talk about inverse functions in this manner. First of all, let's have some definitions. The domain is the set of input values to a function. And the range, and usually the domain is referred to as the x value, and the range is the set of all output values. Oops, that should be one word, output values. And range is usually represented with the letter y. Well, a one-to-one function, I think we talked about this before, but each input has only one output, or has exactly one output. That makes it a function, and one-to-one means each output has exactly one input. So it has two things. And a one-to-one function, the graph passes both vertical and horizontal line test. The graph of it does anyways. All right, an inverse function, inverse function reverses the input, which is the x value, and the output, which is the y value. That's what an inverse does. It reverses it. It just switches it. Switches the input with the output. All right, now here's some new notation. The inverse of a function has a notation like this. You use the same letter, whatever it doesn't have to be f of x, it could be g of x or whatever. But whatever the function is, you put f, and then in this exponent spot, you put a -1 of x. This does not mean to the -1 power. Oops. Does not mean to the power of -1, or it does. This is not an exponent. In other words, it's not an exponent. It does not mean take f to the -1 power. That's just the notation. You say this f inverse of x. That's how you would say it. If you saw that, you would say f inverse of x. That's what that means. F inverse of x. Only one-to-one functions have inverses, so that's pretty important. If a function is not one-to-one, it doesn't have an inverse. How can we tell that if a function even has an inverse? Well, only one-to-one functions, the graph must pass both the vertical line test and the horizontal line test to be one-to-one. So that's how we can tell if a function even has an inverse. So these questions are, which of the following are one-to-one? In other words, which will even have an inverse? Well, if you get your graphing calculator out, y equals 5x minus 9, the graph of that would look like this. It's just a straight line. Oops, you can't even see what I drew. It's just the graph of a straight line. So this passes both, so this would be a yes. This one is a parabola because it's an x squared, so you know somehow this graph is going to be a U-shaped graph. This would be no, because it fails the horizontal line test. This one passes VLT and HLT. This one fails the horizontal line test, if you can see that is an HLT. And 3 minus 5x, well, if you put this in your graphing calculator and graphed it, you would see that this graph looks like this. And this is a yes. It passes both. So linear functions have inverses. Quadratic functions do not have an inverse. Over to page 4, the inverse of an equation. So now to find an inverse, you are going to switch x and y. That's the important thing, to switch x and y and then solve for y. If the function is written in f of x notation, you are going to change f of x to a y, because you know that f of x is the same thing as y. So if you're ever asked to find the inverse of something and it has f of x equals, you just take the f of x out and put a y in its place. So these 3 examples say find the inverse of the following functions and then evaluate b and c at the indicated values down there. So part A, or question A, says find the inverse. Well, find the inverse, you first switch x and y. So instead of y equals x minus 7, you would get x equals y minus 7. So that's the first, that's the first step, is just to do the switch. And then the second switch is to solve for y. So you're going to add 7 to both sides, and you get x plus 7 equals y. So the inverse of this is y equals x plus 7. The inverse of x minus 7 is x plus 7. The second example, you are given an f of x, so the first thing you're going to do is put a y in its place. Y equals 3x minus 9. After you get the y in there, then you're going to switch the x and y. So it's x equals 3y minus 9, and then you're going to solve for y. So you're going to add 9 to both sides first. And it reads x plus 9 is equal to 3y. And then you're going to divide both sides by 3, which means everything gets divided by 3. So the 3's cancel out, and you're going to get y is equal to x over 3, which is the same thing as 1/3 x, plus 9 over 3, which is 3. So that's the inverse, and you can write this as f inverse of x, because it was given to us as f of x, so you should give the inverse with the inverse notation. So that would be your final answer. Now find f inverse of 4. Well, f inverse of 4, you just replace the x's with 4's. So 4 over 3 plus 3 is equal to f inverse of 4. Well, 4 over 3 plus 3 over 3. Well, 3 over 3 is the same thing as 12/3. You can do this in your calculator if you wanted to. 12/3. So 4 plus 12 is 16/3 would be equal to f inverse of 4. In this last example, you're going to take the f of x out and put y equals 1/2 x plus 1. What's the first step? Well, the first step is to switch x and y. So you get x equals 1/2 y plus 1. And then what do? You solve for y. So you're going to add 1 to, or subtract 1 from both sides. So you get x minus 1 equals 1/2 y. And how do you get rid of 1/2? Well, a lot of people say divide both sides by 1/2, but please don't divide by a fraction. In order to get rid of a fraction coefficient, you're going to multiply by the reciprocal. So please multiply both sides by the reciprocal of 1/2, which is 2. And if you multiply this side by 2, then you're just going to get a y left. And if you multiply this side by 2, you're going to get 2x minus 2 if you distribute. So the inverse, we're going to write it as f inverse of x is equal to what we just found, 2x minus 2. And now let's find f inverse of negative 2. So all we're doing is replacing that x with a negative 2. So we have 2 times negative 2 minus 2. Well, this is negative 4. Negative 4 minus 2 is negative 6. On your own. Well, I wonder if you can do this on your own. It asks, does this have an inverse? explain. Well, before we wanted to see if this was 1-to-1, and we had some rules on whether or not it was 1-to-1. So I want you to answer this on your own. Does it have an inverse, do you think? And explain your answer. If yes, why? If not, why not? This next one, does y equals 9x plus 2 have an inverse? Yes or no? Let's see you fill that in. And explain why. What about number 3, 3x squared minus 5x, minus 5x plus 2, does that one have an inverse? Yes or no? And explain your answer. Number 4, find the inverse of y equals 3x plus 10. Well, it's almost like letter B up there, so there's not too much to do if you can just follow the previous example. And then number 5, find the inverse of a third x minus 6, which is almost like letter C up at the top here. Let's see if you can find the inverse of a third x minus 6. And then after you're done, find f inverse of 5. So I want you to finish this. This is on your own. I'm going to check this when I check homework tomorrow, that you've attempted these 5 problems on your own. Now we'll move over to the page 5. Sometimes functions are given to us as a set of ordered pairs, which are just like a set of points. X, Y. Ordered pairs are x, comma, y points. So a function is 1-to-1 only if the range corresponds to only one domain. So in other words, you don't have any duplicate y values, or you don't have any duplicate x values. So if you remember from the previous page, to find an inverse, you just have to switch the x and the y, and if it's an equation, you solve it for y. Otherwise, all you do is switch x and y. So if you're given a function that are just a set of ordered pairs, first of all, this is 1-to-1 because 3, 4, and 5 are all different. 6, 7, and 2 are all different. So the x's and y's are both different. So this is 1-to-1. So if you want to get the inverse of this, all you have to do is switch the x and y's. So 3, 6 becomes 6, 3. 4, 7 becomes 7, 4. And 5, 2 becomes 2, 5. All you're doing is switching. And I'll tell you, I've seen so many people over the years, when they're asked to find f inverse, they look at this -1 and they think you have to make some of these numbers negative. But notice nothing is negative here. All you did was switch the x and the y values. It's so easy. Switch x and y. That's all you have to do to find an inverse. So this is just summarizing the inverse functions. How to find an inverse? How to find an inverse. And it depends on how f of x is given to you. Like I just showed you up here, if you're given ordered pairs, like this is a set of ordered pairs up here, if you're given ordered pairs, all you do is interchange the x and the y coordinate. It's so easy. A kindergartner could do it practically. If you're given a graph, what you're going to do is reflect over the line y equals x. Now y equals x is just a diagonal line that goes through the origin. And I'm going to just put the y equals x line in here. Y equals x goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, and 10, 10. So there is y equals x line. And then in reverse, -1, -1, 2, 3, 4, 5, 6, -7, -8, -9, -10. So here's the line y equals x. And I'll put arrows on the end, and I'm going to label this as y equals x. Now to reflect this, you're going to just switch the x's and y's. So this point here is -6, -4. This point down here, back 6, down 4. So the reflection of that is going to be at -4, -6. So you go to -4 and down to -6, and you've got the inverse right there. I think I'll do the inverse in red. Up here, this point is -5, -1. This point right here. So -5, -1 goes to -1, -5, which is down here. The next point on our graph is -2, 2, Well, negative 2, 2 goes to positive 2, negative 2, which is down here. This next point on our graph is 3, 5. So this point 3, 5, 3, 5 would go to 5, 3. So you go over 5, up 3, and you have that. Now the next point on our graph, I don't have the dark, oh here it is, here's one, and this point is 5, 6. Well, 5, 6 would go to 6, 5. Here's 6, 5. And then, what else do we have? We have this point, 10, 8 would go to 8, 10. So there we go up here. So I'm just going to connect these. And then you have this graph, which is F inverse of X in red. The first one is F of X. The original one is F of X. The reflection over the Y equals X. This is just reflection. So this is pretty important. I want to put some stars. I should have put a purple star on this one too. And then the rule, if you remember from the previous pages, what you want to do is switch X and, well, you want to get F of X out of there and express everything with just X's and Y's in there. And then interchange X and Y, solve for Y, and then if you're given the F of X, take the Y out and put F inverse of X in its place. Now down here, there's sometimes you're, not very often, but every once in a while you have to verify that they're actually inverses. So in order to verify that they're actually inverses, you have to show that F of F inverse is equal to X and that F inverse of F is also equal to X. You have a two-step process for verification. So what we're going to do here is we're going to verify, we're going to find the inverse of this, and then we're going to verify that it is actually the inverse. So this is y equals negative 7x plus 3. To get the inverse, you switch the x and y. X equals negative 7y plus 3. Subtract 3 from each side, and then divide everything by negative 7. So x minus 3 over negative 7 would be equal to the inverse of x. So there's the inverse. Now to verify or prove, you have to show that f of f inverse is equal to x. So we're going to do f of f inverse of x. Well, how you do that is you're going to cover up the f, you're going to take the f inverse of x, which we just figured out was x minus 3 over negative 7, that's f inverse, and we're going to do f of that. Well, f of x is negative 7x plus 3. So we're going to take the negative 7 from that. We're going to replace this x with x minus 3 over negative 7, and then we're going to do a plus 3 on that. So to multiply these two, we have negative 7 over 1 and a negative 7 in the denominator, so those are going to cancel out, and we're left with x minus 3 plus 3. And if you combine like terms, it just equals x. So that's our first half of our check. Now we also have to verify that f inverse of f is also going to be equal to x. So now what we're going to do is cover up the f inverse, and we're going to write down what our original f of x was. Well, our original f of x was negative 7x plus 3 from the beginning, and we're going to do f inverse of that. So then we're going to go back to our f inverse. When we find our x, we're going to take the x out, just the x, and replace it with negative 7x plus 3. So back here, we go negative 7x plus 3, that's our replacement, minus 3 all over negative 7. That's what this was with the replacement. Hopefully that looks like a negative 7 to you. So that's what f inverse of negative 7x plus 3 is. We're just replacing that. So now we can combine like terms. Plus 3 and minus 3 go away. So we have negative 7x all over negative 7. And then the negative 7's will cancel and we're left with x. And that is the second half of our check. So that's verification. You have to show that first f of f inverse is equal to x, and second you have to show that f inverse of f is equal to x. And that's it for today.